Okay. Good evening to all the participants and today's speaker as part of the free online webinar series on latest trends in collaboration with Keeling. It's a software solution business private limited. As part of it, today we organized a webinar on sheet metal, which is industrial best practices. And today's speaker, Mr. Ravi sir, will brief you all about the applications and the best practices under sheet metal. So the session will be hand over to sir.
Dear participants, please wait few minutes. Raju sir, sir, please continue, sir.
Okay. Hello.
Uh,
Yeah. Good evening, one and all. Yeah. In the series of these webinars, today the topic is about sheet metal design and its development. So first of all, what is sheet metal? Sheet metal is nothing but it's made up of metal, and it's a sheet. We call it a sheet because it will be of a thickness from 0.4 mm, that is 1 by 64th of an inch, to about 6 mm. So this is the range of the sheet metal. Everything that comes under this thing, I mean the metals that are formed in the form of sheet and that comes under this range, we call them as sheet metal. And the if the sheet metal, if the thickness of the sheet metal or the metal exceeds 6 mm, then we call it as plate stock. Okay. And the sheet metal itself will be formed from the molten metal, and it's formed using rolling, and it's made up of it's made from the cold working. And there are so many types of sheet metal that we use in the industry nowadays. They include stainless steel, and there are hot rolled steel and cold rolled steel. And we use aluminium, we use brass, we use titanium, and so many other metals. So the next thing is sheet metal processing. The raw material for sheet metal manufacturing process is the output of the rolling process. So the sheet metal, what we get is the sheet metal will be formed from the molten metal. It is then rolled in between the rollers, and it is made into thin sheets, and the resulting product will be the sheet metal. And typically the sheet metals will be they will be flat rectangular shapes, and if the length exceeds or very thin thickness, and if the length is very long, then it is rolled up into rolls. That's how we get it in the market if we want to buy sheet metals. So the necessary product that we use for some industrial purpose, or any size that we use for some industrial component to prepare a component or something like that, we cut it off from the whole roll of the sheet, and we call that small piece that we use to perform some component, or to prepare a component, we use that particular piece as blank. Uh, and this is the gauge chart. The sheet metal, we measure the thickness in terms of gauges. So for the stainless steel, the gauge is measured like it is in proportion, or it is it will be inversely proportional to the thickness. So if the gauge number increases, the thickness of the sheet metal decreases. So if the gauge, for example, say stainless steel, if the gauge is of 28, it will be of the thickness 0.015 inches. So if the and you can see here the gauge, if the gauge number decreases, the thickness of the sheet metal increases. So for the gauge number 7, the thickness will be around 0.1874. And same goes for aluminium. It differs from metal to metal. So different metal will be having different gauge numbers and thickness. We have copper, and we also have the ounce chart here, and it has different gauge. Say for example, 36 gauge number of copper will be having some 0.0050 inches of thickness, and same goes with brass. So this is the gauge measurement tool that we use in the industry. So there are two types: the round and the rectangular type. You can see here these are the inscriptions that they have given in market standards. So the more the number of the gauge, the lesser will be the thickness. You can see here the number 0 will be having the greater thickness. The same goes with here. If the gauge number is more, that is 31, the thickness of the sheet will be so less, smaller. If the gauge number is 1, that is so less, the thickness of the sheet will be more. And we also have a rectangular or ruler type gauge measuring instrument. And this is a closed view of a sheet metal gauge measurement device. So if the gauge number is 0, then the thickness of the sheet metal will be at the maximum, that is nearer to the 6 mm. So if this exceeds this gauge number, then we call it as plates. If you can ask if what is what we call if the mm or the thickness is below 0.4 mm. If the thickness of the metal is below 0.4 mm, then we call them as foils. Now, example, we use it in the foils in the aluminium. We use it in food wrapping thing in the hotels or confectionery markets. So this is the gauge measurement device. So next we have the sheet metaling processes. There are majorly two types of processes involved in sheet metal processes. They are shearing process and forming process. Shearing is nothing but cutting. So if we cut the sheet metal with some external tools, then by using the applying shearing forces, you know what are shearing forces. So if we cut it from the blank or the whole length of the sheet, then we call it as shearing process. If we and the process in which we won't particularly cut the whole sheet, but we bend it or use the plastic deformation and get the desired product from it, then we call them as forming. So the sharing is the majorly cutting process, and the forming is the bending process by plastic deformation. And there are so many types of operations that we do using sheet metals. The various operations that we do using sheet metals are: number one is bending. In bending, there are so many types of bending. The first one is V bending. So you can see here, this is a die. Die is nothing but a mold. You have learnt about molds, right, in casting and material science. Die is nothing but it's a mold actually. But here in sheet metal industry, we majorly use metallic molds that are called dies. So these are permanent molds. So these are used for the large production of so many these kind of components. If the requirement of these kind of product component is so high, then we will prepare dies like this from much higher or harder steel or iron or some other metal alloys, and we take the sheet metal, we place it here, and the punch is nothing but it acts as the ramp. So it majorly acts as a male product, and the die always acts as a female product. So what we do is we keep the metal sheet in between, and we punch it by using external force on the punch, and we get the desired shape that we require. Here we are preparing the V bending process, that is preparing a V component here. So the punch comes here with force, and it applies force on the sheet metal, and the sheet metal in turn becomes a V-shaped thing. And the same thing goes with the U bending. Here the die shape is of U shaped, that alphabet U shaped, and the die will be the female part. The punch with necessary force presses on the sheet metal and gets the shape of the U. That is the required component that we have. And the another type of bending is edge bending. This is done majorly to avoid because the edges of the sheet metal will always be sharp, so there will be chances of getting cut, or the worker might get injured. So what we use is we hold the sheet metal in a cantilever type. The cantilever is nothing but one edge of the sheet metal is fixed, and the other edge is freely hung. So what we do is the punch comes, and it smoothly or with pressure falls on the, or put pressures on the free hung side of the metal sheet. So what we get is the bent shape. So this bent shape is nothing but the plastic deformation. Because of the plastic deformation, the metal gets a bent shape, so that it will get a smooth surface, so that none of the workers get get affected by it or get cut or something like that. And we have air bending, the other type of bending process. What air bending is here we saw in V bending and U bending, the punch directly goes till the end of the die. So whichever portion is there till the end of the die, the punch goes till there. But in air bending, what we do is we give slight portion in the depth side. That is, the punch will not go entirely till the bottom of the die. It will only go till half or 70% of the die, so that there will be gap at the bottom side of the die. So this is air bending. And the next type of bending we have is offset bending. What is offset bending is nothing but we majorly use this offset bending for the conduits. So what are conduits is the hollow case or the hollow pipelines in through which the fluids or the electrical wire passes. So where we use it, say suppose we are putting a wire on the wall, so there is a pillar in between. So we can't just bend sheet metal or the rod like this, the tube formed sheet metal like this. So we use offset bending. In this, the sheet metal is bent, can be bent so easily like this by applying the force. We have angle bending. Say we require a product like this with 90-degree bent, and again we require some 120-degree bent here. So what we do is we design the punch and die in such a way that the punch die will be having the female part, so the punch will go directly and entirely fix exactly through the die. So we keep the metal sheet here, the sheet metal here, and punch it, and we'll get the necessary angle which we need for the component. And there is curling, the other type of forming process. In curling, we uses the same way. The punch will be on the top side and the die will be at the bottom side. There will be a plunger on which the sheet metal will be placed. So the ram or the punch will come from the upside. It applies pressure on the sheet metal. So what it will do is, as the pressure from the punch goes on increasing, the sheet metal will deform in like a cup shaped thing. We will be having a wire that is wound around the die, upon the die. So this plunger or this sheet metal will go till this. There will be a hollow section here between the punch and the wire. So, and the sheet metal will go on curling at this portion. So, if you need a much larger curve like this, curved or curl portion like this, we use a much higher dia wire here. So, the more the dia of the wire here, the more curl you will get. And we have flanging. Flanging is the same as the bending, in which there will be a if we keep the edge as sharp as possible, the worker might get affected by this. So what we'll do is we will bend it like this. But if you bend it straightly in a 90-degree fashion, there will be more stress concentration with it, and the moment of inertia will be so less with it. So what we'll do is we will use tensile and compression forces here. So the first type of this is the convex type of bent structure. Here is the stretch of flanging. This is called the stretch flanging, and the concave portion of the flanging here we call it as shrink flanging. These are the two types of flanging to increase the bend structure at the end of the sheet metal. So then we have hemming. Hemming is the same as bending, is also a bending process. What we do is we also have heard in the fabrical sections, in the clothes, they'll do hemming. What it means is we bend a structure like this of one portion at one end of a sheet metal here, and we can include another sheet metal here, and we can join them without any welding or without any other fixtures and other things like nuts and bolts or rivets like that. We can directly join those two sheet metals without any external joining processes like welding and other things, but directly by bending the one portion of the sheet metal and joining the other one here. The same goes with the seaming. Here, if you want a seaming more aesthetic look, this gives more aesthetic look or good appearance. What we do is we bend one structure, one sheet metal thing in this manner, and we hammer or we use other machines to join them in a curled manner like this. So this gives a much better appearance than putting the nuts and bolts and rivets and other welding processor or joining processes like that. And the other we have corrugating. If you want a structure like this, the wavy structure, we can use the die here and a corrugating tool here, and we can get a curly or wavy structure like this. And then we have tube forming, the forming process. If you want a tubed structure like this, there will be a punch in this manner with a tube shaped manner. As the force goes on increasing, the sheet metal coils itself to become a tube structure. And we have trimming. Trimming is a surface finish process we use in sheet metal. We use on sheet metal. So the trimming is nothing but, say for example, we have prepared a tumbler like this. This tumbler we can use for cooking purposes or something like that. But we have done this by following a deep drawing process. What is deep drawing process? We'll learn later. And when the deep, the punch goes inside and the die presses it, this structure will form. But the blank will be stretched in such a way that it will leave some bursts like this, or some extended irregular shapes at the top end of the part. So what we do is we cut the part and we take it. So we are cutting the sheet metal here. So it's a shearing process. It's not a bending process, it's a shearing process. That is, we are cutting the extra part, the irregular part, from the real part. So then we have nibbling. Nibbling is nothing but it is majorly done for the intricate or design products. So majorly we can see this in interior designs or something like that, for to give the aesthetic or good appearance. So here what we use do is we constantly, with equal space intervals, cut the sheet metal with a small or pierce through the sheet metal in a straight manner, so that we can get a structure like this, the good or better looking structure like this. And then we have drawing and deep drawing process. As I told here, to prepare a tumbler like this, we use the deep drawing process. What we do is, there will be a blank. The useful part of the sheet metal is placed in between the punch. This is the punch, the ram, and this is the die. See, this will be having a hollowed space here. So this punch will go directly with uniform force through this blank. So what this is, so this is the blank. This will be kept in between this punch and the die. So as this goes and applies force on the blank, it goes on curling to become a finished product like this. So this is the way the tin cans, like the soda cans or Coca-Cola cans or something like that, and the tumblers we use to drink water are prepared. So then we have stretch forming. Stretch forming is also a forming process or the bending process. Here the gripping jaws will be there, which holds the sheet metal in horizontal position like this, and simultaneously the die will be here with the necessary shape that we want to create. And what it does is, this ram will go upside and it will apply pressure on it. So what it does is, and also this side carriages will come or stretch it in the downward motion. So this thing moves upwards, the plunger or the ram, and this carriages will move downside. So we'll get a bent structure like this. And then we have roll forming. Roll forming is nothing but the sheet metal will be rolled between the rollers. In the first station, it will be rolled like this, and then in the second station, there will be a small hollow structure like this, so that it will give a hollowed structure or a bent structure on the sheet metal. And also in the third station, there will also be some rollers, and they will be rolling constantly, and they will also have some hollowed structure here, and which will give a bent structure to the sheet metal that we are rolling here. And finally the product will look like this after all the rolling formation. So that is roll forming. And next we have the dies and punches that we use in sheet metals. So what are dies and punches? As I told, dies are the molds that are permanent molds, which will be in the same as which will be of the pattern of the necessary component that we are going to prepare, that we are trying to prepare. So the die will be of the female part. It will have a structure that the whole blank will fit inside it. And what is punch? Punch is nothing but it's the ram. It's the male part of the arrangement. So the ram, the pressure or the force will be applied on the ram, and the ram will move up and down. There will be so many parts in the whole arrangement, and this is the arrangement of the whole die and the punch. So this downward part will be the die, and the upward part will be the bench, and the blank is nothing but the useful sheet metal part that we are going to use for the necessary requirement in the industry. And there are so many types of the dies and punches that we use. The first one is the simple die. So this is the punch. The punch that we are using here is perforating punch. There are so many other types of operations that we do in sheet metal too. What is perforation? Perforation is nothing but it will be producing the equal spaced surfaces, or sorry, the holes on the sheet metal. If equal space, so many number of holes at one single punch at one single time. So that will be the perforation, and this is a perforating punch that we are going to use here, and this will be the stripper that is kept upon the blank that we are going to use, and this is the part of the sheet metal. It is placed, it is shown in black color, and this is the matrix or the support from the bottom side. So this is the die. So we are preparing a part of this shape. So what we do is the punch comes from the upside and it pushes the blank, so that we'll get a part from this. And we have compound die. Compound die is nothing but it's a compound die performs two or more operations at one single stroke of the punch. So here we are doing the piercing or the perforation. Here we are doing the perforation, and here we are doing another operation of bending or some say, for example, shaving or cutting, like that. So we are performing three operations at a single stroke of the punch. So this is a compound die, and we have the combination die. In combination die, it's also the same. There will be so many number of other operations or mixed operations we perform in it. So this will be the metal plate kept on the die ring. So they'll be having the springs here, and they'll be connected with the pads. So the the punch will come and ram through it, and will get necessary operations at a single stroke of the punch. Then we have progressive die. In this, this will be the final end product that we are going to get. So this is the top view that we are seeing here, and what we do is the punch will be here. There are two punches here. There are two punches. The progressive die is nothing but the sheet metal will be flowing this in this manner. It will continuously, they will be continuously feeding the sheet metal in this manner. Sorry, the punch will be ramming at equal intervals of time. So whichever place we require a hole, we will get a hole with equally spaced, equally distanced holes. So this is a washer that we get finally when it rams through the metal, and this will be the strip that finally is left over. So a smaller hole and a bigger hole we will get at the end. So there are so many machines that we use in sheet metal process. So the first one is the press brake machine. In press brake machine, there are so many. Press brake machine is nothing but it's a machine that is used for performing so many forming operations or cutting operations in a single machine. So this is the majorly or universally used machines in industries to perform sheet metal operations. There are other machines like rolling machines to roll the sheet metals into rolls, and we have turning machines. We have turning machines to turn the sheet metal into necessary rolls and thing. And we have shearing machine. Shearing machine is used to cut, majorly to cut the sheet metals. Grinding machine is used to give a surface finish after all the necessary processes that we have done on the sheet metal, the grinding machine is used to give a surface finish. And we have power saw machine. Power saw machine is used to cut the sheet metal, and we have other machines like fly press and tapping machine too. And we also have the cutoff machine. Cutoff machine is cutoff. There is an operation called cutoff, in which the cutoff is nothing but a necessary component is cut off from the blank, so it will be in the middle, so we cannot just take it off directly. So we use a cutoff machine which will be having the laser beam, so that it will mark the necessary portions to be cut, and we can easily take the component out from the blank. So we have profile cutting machine. In profile cutting machine, we use plasma or laser. So we will feed it in the CNC to the computer. So there will be, if you want, say for example, your name printed on the sheet metal, we will just feed it to the computer, and it will cut the necessary profile on the sheet metal. Then we have puck cutting machine and also notch cutting machine. Notch is nothing but a small cut at the edge or the center or wherever on the sheet metal. So to give a small notch or a small hole, or give a different kind of opening at any edges of the sheet metal, we use notch cutting machine. Then we have bench drilling machine. There will be a bench present. Drilling operation, as we know, it's by using drill bits, we drill a hole in the sheet metal. And we have hand drilling machine, by using the hand drilling machine. And we have TIG, MIG, arc, spot, and stud welding. These are the different types of welding. TIG is tungsten inert gas, and MIG is metal inert gas. Arc welding, spot welding, stud welding. We use this type of welding process to join the sheet metals during various processes in the sheet metal. And we also have the painting booth. Painting booth is done only because at the end of the, say for example, we have got the sheet metal. We used that punch and die to get a necessary product, and then we trim the extra parts or something like that, that is protruded or extruded from the part. So then we send it to the finishing stage, that is the surface finish stage, where we use the grinding machines and use the abrasives and something abrasives to give a better finish using grinding machines. Then we send it, if any joining process is there, we use welding or other joining processes with the help of nuts and bolts, rivets, like that. And then finally, after the sheet metal product is done, then we send it to the painting booth for the painting of the component. Here, this is a press brake machine, which we use to use for the different sheet metal operations. And this press brake machine from the company Nargesa. So what they do is, this is a feeder here, the CNC controller. We'll feed the necessary inputs here, and the dice will be presented, kept at this portion of the machine. So, and this is the RAM. It will be moving in up and down, the vertical motion. So we'll keep the blanks or the sheet metal here, and we feed it. So the laser sensor will detect the sheet metal and give a necessary output or the component that we require. Here I have a small video to demonstrate you how the press brake machine works. As we can see here, so this is a die cavity, the female portion of it, and the laser or the sensor is detecting the sheet metal that the worker is putting against it. So the punch is coming and ramming through the sheet metal and giving, and we are getting a necessary shape required. Here, this is a V bending that he did, and this is the V shaped die, and this is the punch. It comes and rams, and we are getting a V shaped component. As you can see here, this is the CNC controller machine. They have fed all the necessary dimensions here with the input, and the system is giving us the output by giving us the necessary component. So this is a perforation technique. Perforation is nothing but it's one single punch and die, giving us so many evenly spaced holes at a single stroke of the punch. These are the various machines that we use in the sheet metal process. The first one is the rolling machine. It is used to roll the sheet metals into rolls. And then we have turning machine. Here the sheet metal is turned, and the cutting tool is used to cut it in necessary places and with necessary dimensions. And then we have shearing machine. Shearing machine is used to cut the metal blank piece or the sheet metal piece into desired shapes and components that we require. And this is the grinding machine. Grinding machine is used for the surface finish to take out all the impurities or the burrs that are present upon the sheet metal. And then we have power saw. Power saw is used to cut or shear the sheet metals. So this is a power saw machine. And then we have drilling machine to drill holes and to put up or to insert the fasteners into the sheets. And we, as I told, this is the power profile cutting. So we will feed these in terms of inputs to the machine, and the laser or the plasma will cut it with precision and gives us the necessary output that we require. And these are the normal tools that we use in the machine shop or the workshop, general handheld tools. The first one is the hacksaw, and it is used to cut the sheet metal. And then we have files. It is used for the surface finish or the edge finish. This is a scriber. It is used to point where to cut, or it is used as a pencil on the sheet metal. And then we have a hammer to join or hit some nails or something like that. And then we have spring dividers. These are the dividers. We will take these are used to produce arcs or circles on the sheet metals to cut it. And we will take necessary radius or the diameters with the help of the scales, and we will put a circle on it and then use it for the necessary products. And then we have benchwise. Benchwise is used to hold the component in a cantilever fashion, and necessary processes are done on it. This is a tri-square. It will be of 90 degree. It will be having an angle of 90 degree. So it is used for the angle measurement in the sheet metal process. When it comes to the joining process of the sheet metal, we have welding. In welding, we have MIG welding. MIG welding is nothing but the metal inert gas welding. Metal inert gas welding. So where we'll be having a metal and inert gas, and this produces a arc. So we use it for the joining of two metal sheets. Then we have TIG welding. TIG welding is nothing but the tungsten inert gas welding. Tungsten is also used for as a sheet metal. It is the strongest sheet metal too, and TIG welding is also used to joining the sheet metals. And then we have spot welding. Spot welding is also called as resistance welding. Here, two sheets that we are going to join are kept in this manner, and the force is applied at either sides. So this produces a current or arc between these two electrodes, and these two plates will be joined with force or joined. Then we have clinching process. Clinching process is nothing but, say for example, fastener like this has to be placed or placed on a sheet metal. So what we use is, there is a machine. So we place the clinching or the fastener here, and the sheet metal is placed like this, and force is applied from the punch, so that the fastener will go inside and stick to the sheet metal. So this is the clinching process. And then we have sandering process or dressing process. This is a surface finish process. So after completing all the sheet metal operations that we have to perform, these are used to give a better surface finish of the sheet metal. Here we use abrasives with a rough or coarse structure, and and also we use brushes, so that any burrs or any extruded or extended parts is coming out of the prepared component will be taken out by using the sandering process or the abrasives. And then we have, after the preparing, say we prepared a component from so many sheet metal operations, then we have joined it using welding. Then for to take out the excessive particles or excessive metal that has been deposited on the sheet, we use the sandering process to take out all the excessive metal deposit. Then after this too, the sheet metal will also be prone to corrosion. So to avoid corrosion is nothing but the formation of oxide layer on it, or the formation of rust. So what we do is, we use acid bath for the sheet metal. It is also called 8-tank process for the metal treatment, to give the anti-rusting surface. So the first tank will be filled with the alkaline base degreaser. So we use so many grease and lubricating oils during the preparation of the sheet metal component. So to take out these grease and lubricating oils, we will dump it or sink it in alkaline base degreaser, so for up to 10 to 15 minutes. So after keeping this, the grease or the lubricating oils that has been deposited on the sheet metal will be taken out due to the reaction with the alkaline base. So after keeping it for 10 to 15 minutes, it is taken out, and at tank 2 we will be having water rinsing. So jet of water is sprayed or thrown on the sheet metal or the product that has been taken out from the alkaline base degreaser tank. After the water rinsing, in the tank 3, we will be having a phosphoric acid base deruster. So what this does is, due to the reaction with the phosphoric acid, the rust or loose oil that has been not taken out by the alkaline or the water rinsing will be taken out easily due to the action of the phosphoric acid on the sheet metal product. So the rusts will be taken out, and again it is kept for some 15 to 20 minutes in that tank, and then it is taken out, and it is again placed for the water rinsing to take out all the phosphoric acid deposition on the sheet metal. At the tank 5, we will be having titanium base activator or the modifier. This produces a compact, this with the reaction with this, it produces a compact crystal structure on the sheet metal surface due to the phosphate coating. This phosphate coating will help in the production of crystal structure on the sheet metal, and it avoids the formation of rust on the sheet metal. And again, it is kept for some 1 minute, and it is taken out, and again it is placed at tank 6 in the zinc phosphating. Zinc is a very good metal deposit to avoid corrosion. It avoids corrosion. So zinc phosphate protects the metal surface from corrosion, and it gives superior bonding to the metal surface. So this enhances the life of the sheet metal product, and it also helps in the good paint absorption from the metal. And then again it's kept for some 15 to 20 minutes in the zinc phosphate tank, and it's taken out and it is washed with water. And in tank 8 we use non-chrome liquid passivation, and this non-chrome liquid passivation seals the phosphate surface that has been produced on the sheet metal surface, and it gives a better output. So this is the acid bath technique used in the sheet metal industry. And after the acid bath, the sheet metal will be taken out, and to talk about the finishing process, we have powder coating and spray coating. Here, the powders will be formed to form of powder will be taken in a slurry form, that is a paint kind of structure, not so liquid or not so solid kind of structure, and it is sprayed with the use of spray gun on the sheet metal product that we have prepared. And the other kind of coating or the painting or the finishing process is the spray painting. Here also the paint is sprayed on the finished product. There are variety of colors that you can choose with from the spray.
యా యా ఒక్క సెకండ్ వస్తున్నా. ఇక్కడ వాన పడుతుంది అది పెద్ద. ఓకే ఓకే.
Sir, excuse me, sir.
Yes.
Sir, my screen share ಆಗಿದೆ. Your screen is not visible, sir.
Okay. Hello. Hello. Yeah. Sorry for the inconvenience.
Audio is not visible at all. Audio
Is okay. Audio is okay.
Why is it not coming? I don't know why.
Hello. It's coming. Hello.
Sir,
Can you speak?
sir,
Hello. Can you hear me? Hello.
how visible, sir? Please continue.
I'll continue zinc phosphating.
Okay, sir.
Okay, zinc phosphating. Zinc phosphate is a better way or the better solution for the protection of the corrosion or the rust to form on the sheet metal. So this enhances the anti-corrosion ability of the sheet metal. So it is kept, and it also helps in the absorption of the paint in a better manner. So it is kept in the zinc phosphating for 15 to 20 minutes, and it is water rinsed and the tank 7, and also it is taken out and it is kept in the tank 8, that is the non-chrome liquid, to the good or better absorption of the formation of the phosphate surface on the sheet metal product. Then we have the finishing processes. In the finishing process of the after the metal component is created or formed, and also necessary shearing process or cutting processes has taken place, and the welding process has taken place, and the metals are joined, and using welding or other finishing processes, the joining processes, there will be some extra deposition, and it is taken out by the grinding process, which is also a surface finish process. And if to avoid corrosion, we use acid bath or the anti-corrosion tank technique. And after all this, we paint the product, or we paint the component. For this, we use a powder coating and spray coating. In powder coating, then required thing is the powder is made into a slurry. It is not so solid or not so liquid kind of thing, and it is contained in a canister, and it is sprayed. The powder is coated on the sheet metal with the help of a coating gun. And then we have the other technique, that is the spray painting technique. In this also, the paint is taken in a canister and it is sprayed through a nozzle on the component, and the necessary or required color of the product can be achieved. And then we have now the product is painted, or the spray painted, or the powder coated. Then the paint now has to be absorbed by the sheet metal. To ensure this, what we do is we use the heating ovens or conveyors. So the sheet metal products will be hung with the help of these hooks here, and with the help of the conveyor, it is sent from one end of the factory or the industry to the other end. So while passing from the conveyor belt, it passes through the heating ovens. So these heating ovens will be kept in some certain degree of temperature. So these paints will get absorbed by the sheet metal, which helps in the better finish of the sheet metal product. And then we have plating. Plating is done to enhance the aesthetic or the outer look or appearance of the sheet metal, and also to avoid the corrosion, rust of the metal. The first one is the silver plating. Here the silver is used as the electrode here, and with the help of the electrolytic deposition, the silver is deposited on the metal or sheet metal. And we have chrome plating. Chrome is very good anti-resistant metal. So the deposition of the chrome helps in the very good better life of the sheet metal product without rusting. Then we have zinc plating. It is also used for the corrosion resistance, to enhance the corrosion resistance and the long life of the sheet metal product. Then we have tin plating. Tin is also used as an electrode in the electrolytic deposition, and the tin is deposited on the surface of the sheet metal, and it also enhances the sheet metal's life or the durability. So this sheet metal is it's a very important product in our day-to-day life. We use it everywhere. We use it from a small house. We use it. We can see our daily life daily. We use it in our house, we use it in our office, our schools, our colleges. We use it in industries. We see it in outside world, that is the moving cars or the machines or buildings. We see the applications of these sheet metals everywhere. The next one is the applications of sheet metals in different sectors. So where we can find these sheet metals and what are the applications of it. The first of all, we can see it, use it or see it in the appliances that we use in the house. We use spoons, we use plates, we use tumblers, we also use fridges, we use micro ovens, we use everything, TV, everything. So in each and every part of this will be having some part or some metal part that will be made up of the sheet metals. And then we have households. In the households also we use so many sheet metal products. We use plates, we use tumblers, we use utensils, spoons, forks, you name it. Everywhere we use the sheet metals in our day-to-day life. And we also can see sheet metals in hotels, and in hotels or the cooking products that we use will be made or formed by the uh, uh, food grade steel, so it will not corrode so easily, and it will be healthier for us to eat with it. So we can put our food, and it will be safe for us, so we can eat food with it. And also it is used in the households for the interior designs, for the showcase, for the almirah, for the interior designs. For all the things we use sheet metals in the households too. And then we have automotive. In automotive, we can see the usage of sheet metals in bikes, in car bodies, or bus coaches, or the train coaches, and all the major moving vehicles that we see in the day-to-day life. Is one or the other way it uses the sheet metal in its body or the coach. And we have aerospace. The usage of sheet metal in aerospace is so vast. The whole product or the whole aeroplane itself will be made up of the sheet metal. We can see various usage of sheet metal in the aeroplane body, that is the nose, and it will be we will prepare the whole new or the whole part of the fuselage of the aeroplane with help of the sheet metal. And we also use sheet metal for the prepared in using different alloys or different metals for the wings and for the tail fin. And also we use the sheet metals for the missiles or the submarines. And also we use sheet metal for the rocket body and the launching vehicles. We use the usage of the sheet metal in aerospace is so vast. We use sheet metal for each and everything in the aerospace using sheet metal. Then we have machineries. In machineries, the body or the component, the major body component, the outer component of the machines, large machines will be made up of the sheet metal itself. The whole these coverings will be of sheet metals formed or produced or made from the sheet metal itself. And then we have construction. In construction, we find the application of sheet metal for the scaffolding, and we have roofs made of sheet metals, and we have ducts that is used for the HVAC purpose or for the air ventilation and all the things. We use sheet metal for all these things, and also for the claddings and all the construction things we use sheet metal. And computers. In computers, the CPU, the outer structure of the CPU or the inner parts or the support parts that we say are made of the sheet metal itself. And we have laptops. The body of the laptops and other things are also made with the help of the sheet metal itself. And then we have packaging. In packaging, the food packaging, we can see the cans. You can see here the cans, the for the cokes or the soups or all the and all the on all the cool drinks, and also the beer or all the alcohol things are packed inside these type of sheet metal canisters or cans. And Then we have for the shipping containers, the whole big containers which are used in the ships for the voyage or to transfer so many amount of products from one continent to other in the ships, or to move everything that is from one part of the world or the one part of the country or to the other, and the whole ship body and all the things that we use for the, and also for the packaging, we use the sheet metal products. And also we use the sheet metals in the old trunks, as you all know, the suitcases or the old trunks which we used to carry the things or files or clothes. We use the sheet metal. And then we have the softwares that we use to work on the sheet metal. The softwares majorly that we use for the sheet metal are the majorly we use is SolidWorks. These SolidWorks is from the Throught Systems, the leading 3D software developers, and we also use this in this SolidWorks. We'll prepare the 3D model of whichever the part that we prepare using the sheet metals, with the help of virtually with the help of the software. And then we have Dassault Systems CATIA. This CATIA is majorly used in the aerospace industry. The precision of the CATIA is so very much good, and also there are so many plugins, and we can get a better usage of CATIA. In the much better usage of CATIA can be seen in the aerospace industry. It is also from the Dassault system. It is also software which is used for the 2D to 3D conversions of the drawings and the products, sheet metal products. And we also use Autodesk Inventor. The developer name is Autodesk, and the name is Inventor. Here we use all these softwares to first design the component that we have in our mind, and to develop it using necessary tools that we get from the softwares. And then we go with the analysis, that is maybe of stress analysis or any other analysis. And then finally, once the product is approved or the prepared using these softwares, once it comes out of all the design criteria or all the development criteria or all the analysis criteria, only then it is sent to the manufacturing unit in the industry to prepare the product. And in this Autodesk Inventor, we use necessary software tools to convert the 2D structure or 2D model into 3D, and we can use so many other tools to virtually see how the model works, and then only then after all the necessary analysis or the operations, we will send it to the industry to prepare the required product. Then we have Siemens NX, which is also called as Unigraphics. It is also a 2D to 3D conversion sheet metal software. We can use the tools and plugins from this. Then the developer name is Siemens, and we can also use this software to produce the necessary sheet metal product. And then we have Autodesk AutoCAD. Autodesk AutoCAD is majorly used for the 2D drawings of the sheet metals or all the necessary architectural scaffoldings or drawings like that. And the developer name is Autodesk. It also gives so many tools for us to virtually look into the sheet metal product or how it behaves, and then this 2D AutoCAD sketch can be imported to SolidWorks so Autodesk Inventor, and then converted it into a 3D model and see how it works. And we also have CNC programming for the production of the sheet metal products manufacturing. And as I showed the video, we use the CNC programming with the G code. We use the G code with the CNC programming, and we also have Autodesk plugin for that. and we use this CNC programming with the help of the code is called G code to teach or to give input to the machine, and this machine will accept the necessary drawings or the inputs from that CNC code, and it gives a necessary or required product that we desire to get. So this is the brief introduction of all the things that is covered or that we do using the sheet metals. First of all, we get the sheet metal from the ingots that is molten in the furnace, and the furnace and it is rolled into thin sheets, that is hot rolled. Hot roll is nothing but it is rolling the sheet below its recrystallization temperature. What is recrystallization temperature? Is nothing but recrystallization temperature is nothing but a temperature at which the molten metal solidifies itself to get a harder surface. So before that itself, so you can see in the blacksmiths shops or something like that, they will heat the molten metal and they'll hit it. Those are the different kinds of metals or hot rolled steels we can get, and after the sheet metal once prepared, the gauges is used to represent the different thickness of the sheet metal, and after the sheet metal is once prepared, the necessary designs is done with the help of the softwares, and after the design structure is completed with the use of the softwares and the plugins, we use necessary after the design criteria is once completed, we use necessary tools, and we go with the development of the product and analysis of the product with the same software itself, the 3D softwares. And after once the analysis is finished, the required diagrams or the required sketches will be imported or exported to the machine shop, and at machine shop or the industry, they take the drawings and they will go on with the necessary manufacturing products with the help of the sheet metal, using dies, punches, and all the necessary sheet metal operations, and they'll prepare the model with using the operations. And after once the operation sheet metal operations are finished, if any impurities are there, it is taken out using the acid bath or the grinding tools, taken out. If any joining processes are there, we use necessary joining processes like welding, riveting, all those things. And after once the if the excessive deposition of this metal is there, we will take it off using the grinding or surface finish techniques to enhance the anti-corrosion ability of the sheet metal or the product. We use acid bath or the chrome plating or zinc plating to enhance the anti-corrosion of the durability of the sheet metal. After that, we will move it to the painting section, in which it is pre-painted or powder coated, and to help the metal to absorb the paint in a better manner, we convey it to the through the conveyor to the heating ovens, where the degrees are kept in certain amount of temperature, and the paint is absorbed from the sheet metal, and after that the finished product will be sent to the market. So this is the whole webinar of today. If you have any question, you can ask me. So there is a question in chat box. Which type of sheet metal is used in making of car body? Majorly in the automotive sections or the cars, that the major sheet metal that we use is aluminum, because it is it gives a weight ratio, that is less higher, that is lightweight. It gives a lightweight for the whole car body. Even if it will be have, even if we use it with of a big surface area, of a greater surface area, the weight will be much lesser, and the whole car body will feel it much lighter. So majorly we use aluminum for the car body preparation. Any other questions?
Sir, excuse me.
Yes.
Uh, Dear YouTube users, please post your doubts in live chat box. Do you have any doubts? Please post in chat box. You don't have any doubts?
Are there any doubts? Any questions? If there are no questions, I would like to talk about the job and opportunities that we have in the sheet metal market or the industry. Uh, so we have designing and developing department in that we need trained or skilled engineers or workers for the design. They should be having the design knowledge to uh, uh, produce the product, and they should be having the knowledge to how to handle the softwares to give a better finished component. And we also have the fabrication sector. Fabrication sector is the hands-on work that we do on this. Designing is sitting in front of the computer and also and all doing the calculations and designing it in virtually using the softwares. And in fabrication sector, we the skilled worker should have hands-on experience in front of the machine or in the factories itself. And then we have machine operation and the operator who handles the machine in the industry to perform different uh, processes or operation in the industry. Say, for example, the machine operator can be a CNC machine operator. You should be knowing, you should be having the knowledge about the G codes and all that, so that you should give input to the CNC machine, and the machine will take the input and give the necessary output or the required product. These are the different sectors, and we have a production unit, the production, and in that so many hierarchies are there, and supervisors, layman, sorry, the worker, with that, and this supervisor will supervise all the necessary operation that are going in the production sector. And we also have die making, die and tool making sector, where they prepare the whole die itself, the permanent die, in which shape the product or the component to be made. Mm, that is, these are the various jobs and opportunities that you have in the sheet metal industry. Okay, there is another question. Which sheet metal is low cost and more useful application in industries? So majorly we use the aluminum and stainless steel sheet metals in industries. The prices are always will be fluctuating between these two, but majorly we see aluminum in the automotive sector for its less weight and more surface area applications. And steel, we majorly see it in the household or the cooking purpose or the utensils we use, and also in the medicines, and also in the medicinal field. So these two are the majorly used sheet metals in the industry or the day-to-day life. Aluminium is majorly used in automotive sector, and steel is majorly used in the utensils household uh, sector.
Manasa.
Hello, Manasa.
Sir? Sir?
Uh, if there are no questions, can we wind up?
Okay, sir.
Okay.
Sir?
Yes, yes.
Sir, session end చేశారు. సార్ సెషన్ ఎండ్ చేశాను.
Yes.
Yes, yes.
థ్యాంక్ యూ. Dear all, thank you for participating.